I still have a few things to refine, but I just wanted to capture it anyway. So what we have here are the layers of GPT-2 Small. So it's not too big, it's easy to visualize, which is good. There are 12 layers. There are 12 heads on each layer. Each of the heads are represented by balls. So we have layer 0. Now it's purple for something I'll get into in a second. Then layer 1, 2, 3, 4, working all the way up until we get out the top. So layer 11. The reason that it's layer 11, not layer 12, is because we have a layer 0. It's just often a way that numbers are handled with computers, and the conventions carried forward into this. So if I put in a query, so like I would chat with this model anyway, and I just want to, for instance, tell it that I like food. Now, if I measure and visualize, it'll actually render that. So what we have, there's a lot of things going on here. I'll talk through them just slowly. First, we have this bottom layer is actually the purple layer. And we can see the black ball there. That's where we enter what's called the manifold or the residual stream, whichever way you'd like to look at it. And so it comes in, and the first layer, see, they're all purple. They're purple so they stand apart, but notice they're all pointing hard to the right. If I hover over, we can see the angle on these is 53 degrees, 61. So they're all quite similar angles, pretty high angles, around 60 degrees. This one's 91. And they're all a magnitude of around about 5. This one's quite high, 12 of 7. But here we go, 4 and 5, 6 and 7, 3 and 4. So what I've figured is there's a stage where the query is embedded, right? And so they convert the text into a series of numbers. Those numbers then fit in this space, which is all, we'll call it all numbers, all related and all connected in one way or another. And so we have to find where in that space we are, and that process shoots us into the manifold or the stream. And so then we need to slow it down. So now that we're in place, right? So this almost grounds it in place. We've been launched into place during the embedding and the mapping from our embedding dimensions into the residual stream dimensions. And that needs a bit of grounding in our new manifold space because there's a lot of dimensions, there's a lot of things going on. So we need to stabilize a bit. So then as we've stabilized and we're now in place in the manifold, we move up to layer 2. So layer 2 here, and subsequent layers, layer 2, layer 3, layer 4. As you can see, they're all pretty consistent. They're all pretty smooth. They're not doing a whole lot. The green ones are doing a little bit more than the blue ones. And so you can see layer 1 there. It's starting off. It's like, okay, now we're grounded in our manifold in position. We know where we kind of want to be. Which direction are we headed now that we've anchored ourselves? And so layer 2 there has a little bit of direction now. And so we'll move to layer 3. Oh, sorry, layer 1 has the direction. Layer 2, just more or less allowing travel in that same direction. Layer 3, much the same. Layer 4, we've covered a little bit of distance now, not much, but a little. And so we're starting to fine tune our answer. We're starting to push it closer now that we're in range of where we actually want to be. And then we'll move up. And now this part's interesting. I'll try and get a good angle. So let's make it a little bit. Where do we want? We'll go about there. So we've worked up our layers. We've got some direction, we've traveled some distance. We've now adjusted our direction. And so you can see there's quite a reasonable sprinkling of green heads in this area. There's actually a little bit of adjustment going on. So earlier down in our previous layers, make them brighter. We can see they're quite blue. Take that away a bit more. So we've got green, bit of direction. See there, blue, blue, we're traveling. Green, now we're starting to adjust. We're starting to adjust. And look at this pink line here that is essentially the central line of our position within semantic space, within the residual stream, within a semantic manifold. I believe that there's a connection between them, and this tool highlights that geometric relationship. So as we go up, we'll continue up. Now we've made a shift, traveling again. Now you might say, why are all these ones blue if we're saying earlier that green is where the change happens? So we'll try and define once again just the layers we want to look at. We've made a shift, which is just below here. So we've made quite a large shift. Now we've made a bit more of a shift. Now up here, something's happening. And we're getting still a shift back over. What is that? We go to layer 6 now. We can see these are still 70 degrees, 70 degrees, 70, 90. The reason for that, and the reason we still have this shift, is because these heads don't actually have much relative difference between them. So if we go back here, what this means is the angle on layer 4, head 6, is at 91.2 degrees. This one is 85.1. That's around about a 10 degrees difference. Over here, under 15 degrees is small rotation. So as we get up, what we're actually seeing is the whole layer is making directional change, because we have the purple is still shifting, and we can see it's shifting in 2 directions. And that is well, the whole thing is a bit of a PCA calculation to be able to compress the dimensions into something that's representable. However, we can see then as we go up the layers there are quite stable. They're all doing similar kind of movements, and they're working together. They've all come into alignment. Layer 9 and layer 10. Now it gets really interesting again here. We have this sharp transition. Everything gets very aggressive again around layer 9, layer 10. So layer 9 isn't best represented on this example, but layer 9 appears to be where it comes to its decision. And then layer 10 is almost where it acts on that decision. So I've noticed if I ask it a question, now we can just quickly do this while I've got the video going. What is the color of the sky? That'll do. So you can see it's pretty quick to render. Often you need to just scale things to get them where that you would like them to be, or where they actually represent properly. Okay. Now layer 10 is this fella. See how complex that shape is. See how complex the variations in the head are. So because I've asked it the question, we go back to layer 9. You can see we've got that similar sort of transition. We're catching ourselves in the residual stream's position. We're figuring out where we're going. This one, the heads are actually quite a little bit unstable. They're probably searching around a little, trying to cover some sparse information within the manifold to therefore figure out what it's supposed to do in this case. Now, I'm not actually sure. I want to have a look. I haven't seen a grey one before. I don't know what the grey color means. 61 degrees. I'm sorry, I'll have to. I'm thinking grey means there's basically, no, because there's 98. Okay, I'm not sure why the grey. I'll have to look into that one. But we're still at layer 7 there anyway. And then layer 8. Oh, okay. So there's the layers are starting to consolidate. I think. I'll investigate that a bit more and find out what the grey directly maps to, I think. But layer 7, layer 8, layer 9. This one's interesting. We have, once again, all similar angles, all quite reasonable angular intensity. Let's put some balls back so we can have a bit clear. What do we got? Yes. Okay. So what can we see here? So we have 3 PCA algorithms going on. There's one for the x-axis, which is, I think, this way. One for z, which is this way. So both of those we can quite easily see. And then one for y, which is the vertical height. Now, an interesting part is it always seems to go back to the same kind of vertical position as the entry. And all I can put that down to is a dimensional collapse. I mean, if I'm measuring the dimensions in say 768 dimensions, and then I'm trying to represent it as 3, what happens when the high magnitude of all those dimensions is collapsed into only 3 dimensions? It ends up actually representing itself almost as 0, especially if they don't line up. And the entry and the exit don't. So that's why they read as a 0, and it kind of ends up back as where it is. It's actually got an offset there, but I believe that's my rendering error. I'm still working through some bugs. But yeah, that explains why we go up and then down again. It's not like I'm projecting into space. Everything is a measurement. Everything is a real live measurement. All of those arrows, they are picked up from quite a dense little calculation on each individual head, and not just the head itself, but the layering and heads around it. And so we have our answer. We have our reason. Sorry, we get to, that was a big detour. We get to the location where the model decides this is a question and I need to respond. Now you see it's purple and it'll do this big shift now, and then it'll do this violent change where it's almost like it's figured out I need to act. This is how we're going to act, and off it goes. And so it'll always seem to hurtle from layer 10 to layer 11. And then layer 11 has this beautiful, wonderful effect that I think we can see here. And then I'll go back to the original query and we'll see it as well, where it anchors. You see, we've got 10 heads here, all anchoring, pretty much doing the same. 9 are doing near enough the same. And they're almost a reverse of what's going on here. They don't look like it because they're combined different, but the combined factor of all of these is similar to this, the combined magnitude and angle, so vector, I guess you'd call it. And then you always have these two, layer 11, head 0, and head 8. And they're quite fascinating, these little fellas. They it doesn't matter what you seem to do, they're always pointing opposite to the rest of all the braking ones. I say braking because it's like brakes in a car or something to pull it up when it's been shot from layer 10. And then this line here continues on. That's my own projection. Like I said, that's probably one of the parts that I need to work on with my animation yet. But that's where it's at. If I go back to the single one we started with, now I'll click that Y again. Okay, so this was our original query. What is the color of the sky? No, I like food. Okay, so this is the one where we came up and we noticed the directional stabilized and the colors. Oh, sorry, put that away. The colors back around here. They're blue, and that was where we noticed it's because the heads themselves are quite stable, but altogether they're still shifting. And so our layers are still moving. And we work our way up, layers 6, 7. Once again, the whole layer is shifting quite a lot there. Over here to layer 9, where it's quite smooth, not a lot of change. The purple's quite stable. All the heads are quite stable. And then we have this crazy effect of layer 10, where we have 114 degrees. What do we got here? 51. What else? 95, 109. So we have massive angular angles there. And then I bet you I'll find some big magnitudes. There's usually a couple with some big magnitude. I'm not finding them. 8. I saw 8 on this one. So if we compare with the layer before, these must be really small. So these are only 2s. 1, yeah, okay. So it's quite a smooth, oh, look, 12, but that's changing direction. And so we've been up here. Maybe, I don't know. See, none of them are pointing this way. Oh, I got caught by my own trick. Oh dear. Okay, no arrows so much because they're all pointing together. So they've come up and they've got to this point, and green means there's a little bit of variance, like we've got 114 versus 37. Now, I might have to double check my rendering there. I would have thought 37 versus 114 would be red. So I'll look into what's going on there. But then off she flies. And so it goes up here to the last layer 11. And that's where we have these, once again, these 10 damping factors. Well, this one's a little bit different. I haven't noticed if there's consistent breaking heads. I've seen this pattern where one's a little bit different quite often, of the 9 front ones. It's very common for this 10th, oh, what head are we? Head number 4 to be quite different. And then head number 0 and head number 8. Those babies are always, my guess is they're actually projecting the final direction. I think all of these red ones are stabilizing everything that happened before, a little bit like we had to stabilize coming into the residual stream with the purple 0 layer. We get up to here and we need to go out, right? So then I think these give it the clear direction out. And when we only have 2 heads, I guess it gives it a finer dimensional axis to project onto. I'm not really sure. But anyway, that's my, what do you call it? Can you call it a large language model oscilloscope? And then check this out. If I go, I like, I don't know, dogs. And then I've got this second sentence, fella. I like cats. And so what this one will do, this is really sick. This will actually do both of them. Now I haven't got the pink line going yet, but everything else is more or less working. Gosh, my camera controls are not the best. So we'll start back at 0. Opacity fall off can be there. And what we have is both. So if I, set that there, we can see the blue one. And I probably need to work on getting my arrows opacities to change and make it a bit easier to follow. The purple stream would really help too. I'm literally working on that right now. But you can see it's much of a similar pattern. It is different. If I go, well, the first one I had was I like food. So if I do I like food, then we've actually got the same as the first one, compared with our second. And now you'll notice we still have the big sharp jump here on layers 10 and 11, same pattern. It's always a similar pattern unless you change the token stream. And when you change that, some really cool things happen too. But I have both, so I can then compare and I can actually look and see deviations. And they're there. Look, this is a massive deviation. Wow, what a lucky example. Okay. Oh gosh, I need to figure out these colors and cameras a bit better. Okay, so I'm just gonna try and strip it back, take some noise away. If I start down here, we'll go up, similar sort of trajectory, set off direction, stabilize direction, figure out where we're at, make some action on it, come out with our decision. And then layer 9, layer 10 is, see, layer 10's all the way over there. That's so cool. So look at that. Layer 9 is up there and then it goes down and then down again to layer 10 before going back up to layer 12. We've still got that same catching effect, same projection. That's all still much the same, but it's really interesting that layer 10 was lower than layer 9 and then it went back up. If we look at this one, see, it goes down and then it stays going down. Doesn't do that weird abrupt change. So this is the I like dogs is the sentence. So I like dogs puts us over here versus I like food was our original, which is back up. Hang on. Let me go back to I like food here though. I didn't notice. Oh yeah, look at that. I didn't notice that layer change there before, but there it is. Real as shit. I was a little worried my tool was showing a bug or something then in real time, but nope, there it is. The wire's off because it's comparing against different things. When I'm comparing the two like that, you have to shift things a bit to make them represent properly. Anyway, I think that's long enough video. I'm going back to coding.